What's up, streamers, memers, and dreamers? Today, we're going to talk about remainder and factor theorem. Kind of, as an aside, we've already talked about factor theorem. God, this pen, I swear, you guys, if this pen doesn't work one more time, I'm going to complain about it again. I'm not actually going to do anything to fix it, but we've already talked about factor theorem. Factor theorem just says if you do synthetic division, right, you got some numbers, some numbers, some numbers, some numbers, and this number right here is 0, it's a factor. Okay, so you know factor theorem. We'll refresh a teeny tiny bit because every once in a while you need that good little sip of refreshing review material. But remainder theorem is new. And you're probably not going to get why you want remainder theorem. You're like, why would I ever need this? But you know what I mean? Sometimes you got to have that new theorem just in case. You know what I mean? Someday you might be stranded on a desert island. Hang on, let me get my pens going. You might be stranded on a desert island and you're going to have like that palm tree. You know what I'm saying? And it's going to have those leafy leaves. What do palm trees look like? That. And you're going to be chilling here. You're going to be laying on the beach. What does laying on the beach look like? You'd be laying there with your tiny little sawed-off legs because they got eaten by a shark. Right? He's over there. He's like, legs. Right? And then next thing you know, this cannibal is going to walk up to you. He's going to be like, yo, boy. Yo, boy. And then you know what he's going to do? With his super long blue arms, he's going to hold a coconut to your head. And he's going to say, what is f of x equals 3x to the fourth minus 2x cubed plus 18x squared minus 3 when x equals 17? And if you can't tell him right there, he's going to coconut you right in the dome. And then what are you going to do? Right? You don't have a calculator on you. You know, your phone's been dead for weeks. You killed that thing in the first 10 minutes trying to look at memes, even though you don't have signal on this island. But lucky for you, your math teacher taught you remainder theorem, and you can do that stuff in the sand. So let's go learn remainder theorem because someday you're going to need it. Probably not today, probably not tomorrow, maybe not even 10 years from now, but someday you're going to need it. So let's talk about what the heck is remainder theorem. Remainder theorem says that a polynomial, and we'll just call it p of x, right? Some polynomial. With the degree, this means the largest exponent, is divided by some linear factor, x minus a number, a, whatever the heck it is. A is a constant. Then the remainder is p of a. All right, let's break that down. The remainder is p when you plug the constant a into it. Okay, so this is a handy way to plug numbers into something. So we're going to use this to plug numbers in. So let me see. Is this our first example? I think it might be. All right. So here's how synthetic division is going to work. Okay, and you're going to like this because it's actually less work than synthetic division. Okay. What we're going to do is we're going to have this polynomial. P of x is x cubed minus 4x squared plus 7x minus 1. And we want to know, even though we have bad notation, what is p of 2? They're telling us to plug 2 into x. So you already know how to do this, right? You could do 2 cubed minus 4 times 2 squared plus 7 times 2 minus 1. And you could plug all that into your calculator, right? You could do 8 minus 16 plus 14 minus 1, negative 2, 6, 5. I think the answer is 5. Okay. Let's put that in the back of our dome pieces. Let's put that in the back of our mental. We'll save that for later. Okay. Let's check that. Here is how remainder theorem works. You're going to do synthetic division. So go ahead and just set that thing up. L, coefficients. Let's just check that they're all there. 3, 2, 1, nothing. Good. That's an invisible 1. So we're going to do 1, -4, 7, -1. The number you want to plug in, that number goes on the outside. Dose goes there. Remember, and this is not going to get old ever, drop it like it's hot. So you just bring that 1 down. Multiply to the outside. Do what the signs say. Multiply to the outside. Do what the signs say. Multiply to the outside. Do what the signs say. Remember, our remainder is this last number. It matches. Oh my gosh. Oh my god. Go tell your mom. Be like, Mom, why didn't you show me this before? You told me you'd teach me everything I need to know in life. Why didn't you teach me remainder theorem? I'd be surprised if your parents told you they'd teach you everything they need to know in life, but I digress. Anyway, so remainder theorem just says, if we do synthetic division, plug the number we want to plug in on the outside, the remainder is the answer. Okay. And you're going to say, Mr. Rowan, why the heck would I want this? Like, why? This is handy for 2 reasons. One, and I'm not trying to like belittle you here or make you feel bad or, you know what I mean? I'm just trying to be real with you. Students suck at plugging numbers in. Okay, that's a little harsh. Students stink at plugging numbers in. Students stink at plugging numbers in. Okay. 2, sometimes doing big powers, like if you had like x to the 7th and you're trying to plug in 17 to the 7th power is a huge number, and this is going to get out of hand really fast. So it helps you avoid having to do nonsense like this, right? So it makes problems that would be really, really crappy, even with a calculator, a little less crappy by doing them on paper. So, all right, let's go ahead and check some more examples. All right, so it says use remainder theorem. We're going to plug in -1 to this formula here. So we're going to set up our L, write our coefficients across the top, 3, 2, -5. Put the number we want in front, drop the first number like it is roasting, 3. Multiply to the outside, -3. Do what the signs say. 2 minus 3 is -1. Multiply to the outside again, 1. -5 plus 1 is -4. Our answer is -4. And it's that easy. You're done. You don't even have to put the x's back in. You get to skip that step. All right. Let's talk about factor theorem one more time just to make sure that you guys like have functioning cerebral cortexes and your all that squishy gray stuff in between your ears isn't clouded with all that smoke that you're inhaling behind the circle K. So, factor theorem, capitalized factor, of course. A polynomial f of x is has a factor x minus k. So this is just a binomial. This could be like x minus 2, right? Whatever. If and only if f of k equals 0. So meaning I plug k into f and it equals 0. That means x minus k is a factor of the polynomial. And we talked about that last time. So let's go ahead and look at some examples here. So it says, use the remainder theorem to determine if x plus 2 is a factor of this. Okay, so we're going to set up our L. We're going to fill in our coefficients. 3, 8, 5, -7. And remember, I'm checking in the back of my head. 3, 2, 1, nothing. Just to make sure everything's there. Set the divisor equal to 0. Okay, that's this thing, right? So x plus 2 equals 0. Subtract 2. X equals -2. So we're going to put -2 on the outside. You're going to say, Mr. Brown, why didn't you switch it back here? That's because they're telling me what to plug in here. This is the 0. If you look at this, this is in a binomial with the x. Anytime it's in the binomial with the x, you have to solve for it. You can't just plug in the number that you see. You have to use your brain a little bit. So we did step 1. We found the number that goes on the outside. We set up our synthetic division. It's set up. Okay, let's do the synthetic division. Allow that thing to fall as if it were at a very high temperature. 3. Multiply to the outside, -6. 8 minus 6 is 2, times -2 is -4. 5 minus 4 is 1. 1 times -2 is -dos. -7 minus 2 is -9. And now we check. Is the last number a 0? Obviously not. You can see it's a -9. So is it a factor? Not a factor. To be a factor, this has to be 0. Because this is any number besides 0, it's not a factor. All right. Let's do another one. They want to know, is x plus 5 a factor of this thing? Okay. Do we use 5 or do we have to change it? Well, it's in a binomial with an x, so we have to solve for it. So x plus 5 equals 0. Subtract 5. X equals -5. That's what goes on the outside of our synthetic division. Coefficients across the top. 1, 6, -1, -30. Allow the first number to descend with a high temperature. 1. Multiply to the outside. -5. 6 minus 5 is 1. Times -5 is -5. This is -6 times -5 is 30. -30 plus 30 is 0. It is a factor because the remainder equals 0. Done. All right. Rapid fire. They want us to check all this stuff. Okay. The first one is kind of a trick question. Is x a factor? If x is going to be a factor, let me tell you right now, every single one of these terms has to have an x. Because x is not a GCF, this is not a factor. Okay, so for the rest of these, what we're going to do is we're going to solve these to find the numbers we have to plug in. Then we're going to plug them in quickly, if you will. So set this equal to 0. X equals -4. Set this equal to 0. X equals 4. Set this equal to 0. X equals -3. I'm skipping the moving stuff to the other side, but I'm hoping that you can imagine what that looks like. Now we're going to set up our synthetic division. We'll put this here. Let's check our coefficients. We have 1, -4, 3, -12. And now we're just going to go through this list 3 times. Okay. So what I'm going to do is I'm going to lock this stuff down. If you will, I'm going to write it in pen and then do this part with pencil. You know what I mean? Here, I'll even make it look like pencil. There you go. So now we're going to do -4. -4, drop the first one, multiply, -4, whoops. That's -8 times -4 is positive 32. That's 35 times -4 is a big number, right? -140. This is, anyway, it's negative. It's not 0, right? It's -152. Not a factor. Now we erase all the pencil. And we do it again with 4 this time. So drop the first one. 1 times 4 is 4. -4 plus 4 is 0. Times 4 is 0. 3 plus 0 is 3. Times 4 is 12. That's 0. Is a factor. Erase the pencil. I suppose that this part could not be pencil since you always drop the 1 down, but you know, darker color pencil. do the -3. So 1 times -3 is -3. -4 minus 3 is -7. -7 times -3 is 21. 21. 3 plus 21 is 24. Times -3 is -72. And then -12 minus 72 is -84. Doesn't matter. It's not 0. So it's not a factor. All right. And that is remainder and factor theorem. So that was a quick set of notes. Dang, in and out, ladies and gentlemen. Under 16 minutes, unless I can draw out this outro. Make sure you like and subscribe. We just passed 100 subs, so maybe I'll do something special. Probably not, but a boy can dream.